Hey everyone, welcome back. This is Factoring Review Day 2, where we're going to look at factoring trinomials where a is greater than 1, level 2, and then factoring trinomials where a is greater than 1, which is level 3. And that's where our numbers are going to get a little bigger, and then we possibly have to factor out a GCF, which is what we talked about on Day 1. And then lastly, we'll look at some special cases, difference of perfect squares, and then I'm also going to talk a little bit about the perfect square trinomial. So today we'll look at where that first term is now greater than 1. So we're going to have still the same idea of how foiling works in the back of our minds as we start to factor these to find the two binomials. So when your A term is greater than 1, it is similar to the Day 1 review where your first terms are going to multiply to this first term, and then your last terms are always going to multiply to this last term. But your outsides and insides now are going to start to deal with these terms in your binomials now have coefficients. So that's going to change our strategy on how we find that middle term. Your middle term is going to be the result of your outside terms, 3x and 1, and then your inside terms, 2 times 2x. So your 3x times 1 is your 3x. Your 2 times 2x is your 4x, and then those two will combine to make your middle term. Now we'll be presented the problem in a trinomial, but we can use clues about how FOIL works. We know that this 2 is going to be the result of multiplying your last two terms of your binomials. So it has to be a 2 and a 1. So I'm going to note that right there. Now 6, there's a couple ways to get to 6. So we have 6 and 1, we have 3 and 2. There's a couple ways to get there, but we'll use the 3 and the 2. Now what I've done when I've listed these factors is I have really made two binomials that I'm going to do a quick test on. So this is 3x plus 2 right here. This is 2x plus 2. And I'm going to show you next how we can do a little test to see if we can get those outsides and insides to add up to 7x. Now once you've got your factors, 3, 2, 2, and 1, to check your outsides and insides of what would happen in FOIL is you can just take and check these diagonal factors. So 3 times 1, that's 3x. 2 times 2, that's 4x. That's exactly what would happen if you wrote out the binomials. You'd be checking your outsides and inside steps to see if that's going to match up to that middle term. Well, 3x plus 4x does equal 7x. So that does mean now this top two numbers, those are going to equal my first binomial, which was 3x plus 2. And those bottom two factors, 2 and 1, make up my second binomial, 2x plus 1. So now we're going to take that strategy over to that first problem there and start to do some tests to see how can I get to that 19x in the middle. So we'll start by putting factors of 5 underneath. So to get to 5x squared, it's got to be a 5x and a 1x. So we don't have any options there. 5 is prime. That's what we're going to do. Now we need to multiply to negative 4. Now looking at negative 4, I see using a factor of 4 because I need to somehow get to this 19. So I'm going to put the 4 diagonal from the 5 to get to 20, which is pretty close to 19. And then I'm going to put a negative 1 right here. So right now I'm testing the factors 5x minus 1 and then x plus 4. And now I'm going to check the outsides and insides to see if that's going to add up to 19x when I do that. So I'll check 5 times 4, which is 20x. Then I'll check 1 times negative 1, which is negative 1x. And that's going to add up to 19x. So now I know my factors are 5x minus 1 and then x plus 4. So now I'll type in 5x minus 1 and x plus 4. So remember, 5x minus 1 are my factors, and then 5 times 4 would be the outside two terms of those factors. So there it is, 5x and 4. And then x plus 4 is my other factor, which makes my negative 1 and my x term the inside terms. So we checked the answer, and we did get that correct. You can kind of see their work as well. They're checking the outsides and insides. I just like to put the factors below and just do a quick check so it doesn't take up as much room and things like that. And sometimes you can just do it in your head. So now we'll take a look at this problem. Again, I got my first term is prime, so that has to be a 3 and a 1. And then I need to multiply to 5, which is also prime. So that has to be also a 5 and a 1. Now I'm going to strategically set it up so that I can somehow add to 8. Now if I put the 5 right here, that's going to make my insides 1 and 5, which is 5x. And I put the 1 right here, that's going to make my outsides 3x. So I do my diagonal, 3x plus 5x, that's going to equal 8x. So now we're set. So now we can type in our answer, 3x plus 5, and then x plus 1. So what do the Ivy Leaguers, the smartest guys in the room, make of this? Can't they understand that this is a fairly central contradiction and perhaps they should reconsider that belief that strikeouts don't matter? So here I go on my third problem. We'll try one more. We've got another prime. Has to be a 3 and a 1. Now to get to 9, there's a 9 and a 1 that we could use to multiply to 9, and then also a 3 and a 3. But I need to get to 28, which is a pretty big number. So if I put the 3 and the 9 diagonal from each other, that would be like my outside. So just I'm always thinking back to that would be this multiplication, this 3x times 1. That would be this 3 times 9. That gets me to 27x. And then I put the 1 right here. That's going to get me another x to make 28x. So again, I've got a 3 times 1, which would have to multiply to 3. 9 times 1 multiplies to 9. I have to get those to work. But then your outsides and insides have to add to 28. So we've got that. We do this. 9 times 3 is 27x. 1 times 1 is another 1x. That's going to add up to 28x. So that's going to be our factors. So we'll go ahead and type that in, and that should be then our result. So our top row is 3x plus 1. We got that entered. X plus 9. That should be our factors. And there we go. There's our result again. All right, let's move on to level 3. So as we look at this problem, we're going to check to see if we have a GCF. So 6, 23, 35, 23 is prime, so we do not have a GCF. So we'll use our strategy, find factors of 6, find factors of negative 35, and then try to get those outside-inside terms to add to 23. So in this situation, I like to start with the factors that are closest together to each other. So we'll go 3 and 2 to start out with that 6. Then to get to negative 35, I have to use a negative 5 and a 7 because one has to be negative, one positive. Then I can check my outsides, 21. Check your insides, negative 10. And you ask yourself, does that add up or subtract to that middle term? No, so we did something wrong. So we're going to erase and start again. Since I'm dealing with a negative number, I'm going to be dealing with the difference. I have to have a difference of 23. So instead of using 3 and 2, I'm going to use 6 and 1. That's going to still multiply to 6, and then that's going to allow me to get some bigger positive numbers. So let's see if we can try this one. Now I'm noticing that if I do 6 times 5, that gets me to 30, and then 23 is 7 less. So if I go the 1 in the negative 7 diagonal, those outsides would give me 30. These insides are going to give me negative 7. That's going to add up to 23. So that makes my two factors 6x minus 7 and then x plus 5. So again, we check it. That works. The 6x and x make the 6x squared. The negative 7 and the 5 make negative 35. We always know that we're going to get those two terms. Now we just got to find that right combination that's going to add up to that 23x in the middle. Let's go ahead and try another one. So as we look at this, we've got a 4. So we'll start with, let's try 2 and 2. Then we've got a 9. Let's try 3 and negative 3. We'll just see if that works. And you check that out, you'll get your outsides to be negative 6, your insides to be 6, which makes 0 in the middle. That's actually a difference of squares that I just set up right there, which we'll see next. So that's obviously not going to work. So I'm going to change up my factors. I'm trying 4 and 1. That's going to multiply to 4. 9, negative 1 will as well. So I check my outsides. I'm going to get negative 4. Check your insides. 1 times 9 is 9. That's going to add up to 5. And the more you practice with this, you'll start to see it. Okay, I got to get 5 apart. Well, 4 and 9 are 5 apart. So I'll just use a 1 and a 4, 9, -1. We'll start to get our results. So our answers now are 4x plus 9 and x minus 1. Remember your answer, your binomials just go straight across, 4x plus 9, x minus 1. So we go ahead and try that, and that was the correct answer. So there's your level 3. You may have to try some different combinations of numbers, but it is kind of a guess and check method. And as you practice more, you'll become more and more comfortable with factoring these trinomials. Lastly, we'll take a look at a difference of squares. So the big thing you'll see when you're factoring a difference of squares, you only see 2 terms. And difference means that they are subtracting. So that's going to be your difference of squares. So we have 16x squared minus 121. We're going to talk a little bit about, though, where do difference of squares come from? In a previous problem in this video, I tried to use 2x and 2x and then 3, -3 as my outsides and insides when I was trying to factor a trinomial. Well, let's FOIL this out and see what happens when you multiply a 2x plus 3 and a 2x minus 3. When you FOIL out, you'll get your 4x squared, your -9 when you do your first and your last, but your insides and outsides is what something special happens. You got a outsides of 2x times -3, which gives you 6x, but then your insides, a 3 times 2x gives you a positive 6x. Every time you multiply two binomials like this, where you have the same terms in each, but one's a plus, one's a minus, you're going to get these middle terms always to cancel out, and you're just left with then 4x squared minus 9. Now, there's also something special about 4 and 9. So these are special types of numbers as well. These are numbers that you can always square root. So your square root of 4 is 2, square root of 9 is 3. Those make up your terms in your binomial. So take a second to look at 16, 121 and start thinking about what are the square roots of those two numbers. Well, you should see that the square root of 16 is 4. The square root of 121 is 11. So I'm going to have a 4x plus 11 and a 4x minus 11. So no matter what, when I do my FOIL, 4x will give me 4x times -11 gives me -44x. The insides, I get a positive 44x. Those are always going to cancel out. And we submit our answer. And there's our result. These two binomials have a special name. They are called conjugates, and we will keep learning about conjugates when we get to imaginary numbers and when we start getting with the quadratic formula in this chapter, solving out. But the big idea is a difference of squares. You'll always see perfect squares, and you'll only see 2 terms, and they are being subtracted. So again, you can take a look at 36x squared minus 49. Think about what's the square root of 36? What's the square root of 49? So you should notice that the square root of 36 is 6. So that's going to be 6x. Square root of 49 is 7 plus 7. And then we have a 6x minus 7. So there's your difference of squares. And submit our answer, and then that should be our result. The last thing we'll take a look at is a perfect square trinomial, and this will pop up when we start looking at solving by completing the square. We're going to be dealing with these perfect square trinomials. You can factor them using strategies that we've talked about. So in this one, we have a term of 1. We're trying to multiply to 9, add to 6. You probably already see it. It's going to be 3 and 3, because 3 times 3 is equal to 9. 3 plus 3 is going to add up to 6, which means the factor is x plus 3 times x plus 3. Now, anytime we have two factors that are exactly the same, we can write those using an exponent. So the actual final answer that I want you to express your answer is x plus 3 squared. So using that exponent of 2 to show that you have two of those factors, x plus 3. So that concludes day 2 of factoring. This is hopefully some review and hopefully maybe freshens up some of your factoring skills. But we will continue to use these skills throughout the year. So it's definitely a very important skill as we continue. Thanks for joining. We'll see you next time.